All right, so this topic, one of the main overall themes of this is sustainability and also what we call the health and safety of PVC pipe. Not a lot of people are actually interested in this topic, but let me tell you why though this is kind of important to at least just be aware of and keep in mind. Number one, this is a topic that's being talked about a lot about our pipe. So you're gonna hear some things, PVC pipe is dangerous. So hopefully this will kind of help keep the record straight. And also, you never know if a client will ever come to you guys and say, hey, we're getting pressure from our city council, we need to show how this project is sustainable, or the sustainability of this project. So these kind of things do come up, and so hopefully this will help you guys be aware of what you need to know. First, I'm gonna start with sustainability of PVC pipe. Okay, so what is sustainability? What's a good what does that mean? I mean, and I'm gonna ask you guys, if anyone wants to volunteer to answer, what in the world does sustainability mean? If you ask different people, you'll get somewhat different answers. I think we just saw that, right? Or some people will stick to a certain definition that they saw with some organization. Once I've done this before, someone gave me the exact dictionary definition, like Merriam-Webster dictionary. So, this is a term that's it's a very generic term in a sense, especially when we use it in conversations or colloquially. Now, when we talk about what makes a pipe material sustainable, now we got further context. And so we got to try to find out, in this context, what does it mean for a pipe material to be sustainable? And maybe it could fit some of the definitions that you guys said. So if you ask this question, what makes a pipe material sustainable? Again, if you ask it to one pipe material manufacturer, you'll get one answer. If you ask a complete different pipe material manufacturer, you'll get a complete different. Each pipe industry has their own answer. So for example, one industry will say, well, our pipe is sustainable because we used recycled material in our manufacturing. Another one will say, well, we use just 2 or 3 natural ingredients in the manufacturing. Someone will say, I don't know, our pipe lasts 100 years, something like that. You'll get different answers. And the thing with these answers is they're very qualitative in nature, right? Okay, so you use recycled material. What does that mean? How does that help me know how sustainable it is? How does that compare to this other pipe material? So these kind of qualitative natures, they don't really help us too much, right? They don't really tell us anything. They're good to know. I'm not saying there's anything wrong with that, but it's not the best kind of answer, especially if we really want to know what makes a pipe sustainable. So you see these two terms here. I say that these terms actually will describe the sustainability of a product. All right, embodied energy is the sum of the energy that's used throughout the life of a product. And environmental impacts, that's how that product impacts the environment throughout its life. These terms are actual numbers, they're values, okay? So like embodied energy is like how many joules of megajoules of energy, or I guess BTUs of energy. Environmental impacts, there's different categories. You'll see them later in this presentation, but one category is like global warming potential. That's the unit for that is the amount of CO2, equivalent CO2 that's released. So that's your carbon footprint, okay? So these are actual numbers. So I think, if you guys agree or disagree, if you know the values, these two values for a pipe product, then you know everything about its sustainability. You know how much energy and how it's impacting the environment, okay? And with these numerical values, you can then compare with other similar products. Then you can say, okay, this one is more sustainable than the other, okay? Having this information will help you know about the sustainability of a product. Now, when it comes to those kind of qualitative answers, that they aren't bad, they're not as helpful as something numeric. But keep in mind, these are just some of the things that we've listed on here. I think the most important things that you'd want to see in a product for sustainability, I think the best things are corrosion resistant and 100-year life. Basically, I'll just say is that pipe, when it's in the ground, you don't want it to degrade and you want it to last, okay? That's how you can meet those definitions of sustainability. But keep those in mind, and then there are some other properties that we list on there. But now I'm gonna get into how we find those two values that I said, all right? By the way, this presentation, it has a lot of bullets. I don't want you guys to bore yourselves reading through. I'm gonna summarize each slide. Okay, so the way you find those two values, those two terms, it's called a life cycle assessment, or an LCA. A life cycle assessment, it's a study that's done on a product that looks at the entire life of the product everything that goes in and out, any resources, any energies, and then you can determine those two numbers, okay, the embodied energy and environmental impact. So after you do an LCA, there's another document that's done, it's called an EPD, Environmental Product Declaration. So an EPD is just a document that gives the results of the LCA. And there's a reason why that's a thing, why there's a thing called an EPD. I'll talk about that in a little bit. But this is how you've determined those two values, and how how is it transparent? How does a manufacturer release that data? It's through this process. You do the LCA study, and you do an EPD document, okay? So anyone can do an LCA study, and in fact, even a manufacturer can do that on their own product. A researcher, a scientist, anyone can do an LCA on a product. Because anyone can do it anytime, anywhere, it's best if we have standards, right? So we want to follow a standard. There is a standard for doing an LCA study. It's under ISO, International Standard Organization. It's ISO 140 series. And so there's a few different standards, but basically there's two here, the 040 and the 044. That's how you do the LCA. And then the 025, that's how you do the EPD. So luckily there's a standard out there that you'd want to make sure the LCA and EPD follows this, right? Because you don't want just someone to do it out willy-nilly. The good thing about this standard, actually what makes the standard very great, is that it requires third-party review and third-party certification. This is what makes the standard stand out amongst any other organization that does LCAs or certifies green certification stuff. If you do it per the standards, you have to have third parties review it and third parties certify it. And in my opinion, that's what makes these standards the most robust way to do LCAs, okay? So just keep that in mind. ISO standard LCAs, it's a very good thing. That's what you want.
How long have those standards been around?
I don't know, but they're not like that new. I mean, they've been around for a long time. That's all. I don't know exactly what year.
Are they recognized in the UNESCO's? Really, UNESCO's?
Correct. Yeah. Right. But for doing things like LCAs and EPDs, this is done around the world. There are some organizations, they call them green organizations, that don't do this. Only because they think that they're authoritative enough. I'll mention that in a later slide. But this is done around the world for different industries, different products.
They published the second edition of 14040 in 2006. So it was probably for 20 years now. It's probably there.
Okay.
Yep. There was other thing I was going to mention, but anyways, okay. So that's what's important what's good about doing it per these standards. Okay. All right. So the LCA, basically when I say it's a study on a product, it looks at every stage in the life of a product, okay? So if you can't see that, basically the initial stage is the manufacturing. So here you have the raw materials. That's where it begins, the study, how the raw materials are manufactured. So it's even before the final product. All right, so raw materials, so for PVC pipe, that's PVC resin, okay, how PVC resin is manufactured. Then the manufacturing of the product, the installation and the use of the product, and then the end of the life. So, different, like let's say this laptop here. If you do this, then you may have to look at the end of the life of the laptop, like disposing it. Water mains and sewer mains, there's really no end of life stage because the pipe just stays in the ground. Even if you replace the pipe, that pipeline's still in the ground. So when this LCA is done on pipe, you're just looking at all those stages up to installation and use. Okay, so that's what this study looks at for PVC pipe. All right, don't worry about reading all this. Basically, the PVC Pipe Association was the first and still the only pipe industry to do an ISO LCA and EPD. Okay, so what does that mean? First thing first, we have the results transparent to you guys. All right, so any end user can literally look in these documents and they can see those values, how much carbon output and how much energy does it take to make the product, okay? That's number one. Now, number two, it was third-party reviewed and verified. So a company called Sustainable Solutions Corporation, they're a environmental firm, they did this LCA study. And I'm going to show later, there were 3 experts that reviewed it, and then the EPD was verified by NSF. So NSF basically, so Sustainable Solutions wrote the EPD, NSF verified it. So that's the third party that we're talking about, okay? So again, we're the only ones, no other pipe material. I think there one pipe material for storm sewer has done it, but for water and sewer, we're the only ones, okay? All right, so we did this back in 2015. This is the first page of the 2015. You can still find this on our website. What you have in front of you is the newer 2023, and I'll talk about that next. But this is the first page of the 2015 one. If you zoom in, one box has the EPD information. And so I just wanted to highlight this right here. This EPD was independently verified by NSF International. If you look at a box below, it says this LCA, so the LCA study, was reviewed by, and it lists 3 people. These are like experts in the industry of LCAs. So we had 3 third-party people review this LCA study. All right, so just to recap on the stages, the product stage is all the manufacturing, from the raw materials to the pipe. The next stage is the transportation of the pipe to the job site and the installation of the pipe. And then the next stage is called the use stage, and that's anything that requires energy during the use of the pipe, when the pipe is in operation. Now, there's really only one thing that really uses a lot of energy, and that's pumping. All right, so pumping water through the pipe, I mean, that's really where you use most of the energy when that pipe is in service. And then there's end of life, but again, we assumed that energy is 0 because there's really nothing done at the end of the life of the pipe. All right, so the LCA study was done on these different PVC products. For C900, it's different sizes, 8-inch and 24-inch. And then C909 was also looked at. I'm going to talk about C909 next in my next presentation. But then also PVC sewer pipe, solid wall sewer, and corrugated for stormwater. So these were the different products. Now, before I get into the results, I'm not going to, for time reasons, I'm not going to show the actual values for this study. I think I'll do it for the 2023. But what I wanted to show is, once we did it, we had the results for the PVC pipe, right? But the next question that came up was, okay, well, what does this mean? So for PVC pipe, it has this carbon footprint. It has this much energy total. But how does that compare to other pipe materials? That's really the useful information. And in fact, that's the whole purpose of an EPD. That whole standard is laid out to where an EPD can be done if it's done for one product. A similar product can be done if you do the same EPD for that other product. You can compare. Basically, EPDs are meant to compare different products, the LCA results, okay? So now we wanted to see, all right, we have the numbers for PVC and PVCO. How does that compare to other pipe products? Now remember, we're the only ones that's done this, all right, for ISO standards. But what Sustainable Solutions Corporation, what they did was, they said, we'll do some research and we'll write a report that not only shows the LCA results for PVC pipe, but we'll look at other papers done on other pipe materials. And so they found some information done in other countries for these other pipe materials, because again, it hasn't been done in North America. And these are not ISO certified either, but it's just what's available. And so they wrote a report and they did a comparison. So that's what I'm showing here. This is PVC, this is PVCO, and then you have HDPE and ductile iron. The blue is cradle to gate, so that's manufacturing, right? When that pipe is made to when it leaves the plant, that's cradle to gate. The red is installation, transportation installation, and the green is pumping energy. Okay, so that's what we call the use phase. So even when you look at other studies done on other materials, PVC comes out to be lower. So just wanted to point that out. Not only do we have the results, and it's for anyone to look up, but we wanted to compare it, and we found that we're lower than other pipes. Okay?
So I have a question about the comparison between DI
Mm-hmm.
and PVC. So it's about the same, right? If like PVC DR 18, the use phase,
Oh, yeah. So, okay, I will show the use phase in zooming in on the use phase, but the use phase is bigger. Well, it's hard to tell, but it is bigger. Yeah, but it doesn't look like by much. I think because, so this is looking at 8-inch, and I think that's why they look kind of close. But, so this is 24-inch. Yeah, it still actually looks up. But anyways, it is bigger. So, okay, this is 24-inch, and I'll show the pumping energy next.
yeah.
So yeah, just pumping, the 24-inch just looks at HDPE ductile and pre-stressed concrete cylinder pipe. So similar deal, PVC. As far as, this is total energy use, by the way. This is megajoules per 100 feet. Total energy use, PVC has very low energy usage. But you can see so you made a good observation. Pumping energies look to be somewhat similar. The biggest difference is right here, the manufacturing. So to manufacture PVC pipe, relatively speaking, takes a lot less energy than other pipe materials.
So the, for the cradle to gate.
Yeah.
Okay. So between HDPE and DI, is HDPE supposed to be cheaper than DI?
Oh, it's cheaper, but
So if it's cheaper than the
no. So cheap. There's a lot of factors that go into the cost, but what goes into the amount of energy used to make it? It's a lot more material. So the raw ingredients itself can be cheap, okay? But if it's a lot of energy to put all that material together, then it's going to be more. Now, but again, keep in mind, I don't know what country but this is from some non-North American study that, so again, it's just the best information that we have.
I think with HDPE on the cradle to gate, you have to be considered that it's a weaker material, so you need much more material to handle the same stress. So it's reflecting the fact that the wall thickness is 2 to 3 times as thick in HDPE, so it takes more energy to manufacture it.
But should everything be reflected in the price?
You're right. It's a good question, but I don't think it's a direct correlation of. So like the most expensive material, it wouldn't be like that, like cheapest material less. Because I think there's more to it than just, energy is cost, but there's also other things that add into cost. Another thing, so this is, just cradle to gate. So anyways, I think when you have so much material of HDPE, it's going to be a lot more energy. Okay, so now this gets in, so we're zooming in into the use stage, which again assumed just pumping energy. It just assumed how much pumping energy throughout the life of the pipe. So one of the main assumptions that was done was for the metallic pipes that have cement mortar lining. The authors of that report assumed that the Hazen-Williams C factor decreases over time, or in other words, the friction increases over time. This can happen in cement. There's papers done on this, and Uni-Bell, this is a document we have on our website. We have a page that shows data that shows that. So this was the assumptions that were used to determine those pumping energy. This is the Hazen-Williams C factors. They actually assumed a slight decrease with even plastic pipes, PVC, PVCO, and HDPE. But the cement mortar line pipe, they assumed starting from, this is what you find in literature, C factor 140. But they assumed there was a gradual decrease over time. And so they talk more in detail about how they modeled that. So here it is. This is the zooming in. And this is for, 8-inch pipe. So again, you just see a higher pumping energy for the other materials. What's unique about why PVC has lower compared to even a smooth interior like HDPE, there's two factors, right? There's the internal diameter and there's the C factor. So PVC is like a good in between. It's a little more thicker than ductile, at least PVC is, but it's a more smoother. It's a higher C factor. HDPE and PVC are both smooth, both C factor 150. But HDPE's internal diameter is a lot smaller, right? So it's just very interesting, like optimization, if you will, but or combination there. Okay, this is just a graph that was in the LC report. They just kind of looked at if you, This is how much carbon, I think from cradle through installation. If you were to monetize that, if you were to put a dollar value, so this is not pumping energy, this is just the carbon output from cradle through installation. It's just another way to visualize that difference. All right, so that was pressure pipe. That was C900 and pressure pipe. The same thing was done for gravity sewer pipes. I don't think I show it here. Well, anyway, this just looks at, this is embodied energy. So this looked at PVC versus other corrugated type polypropylene, polyethylene, and also, ductile iron, clay, and concrete pipe. Okay. The report also added flow comparisons for sewer pipe because in sewer pipe you don't have pumping energy, right? So there was no use stage, but the authors just wanted to put just a flow comparison, hydraulic flow comparison. But this just points out that for sewer pipe, with PVC you can get more flow on the same slope, and this is 24-inch pipe, right? But even if you look at this bar here on the far right, a size smaller, which is 21-inch PVC, has about the same flow rate, very comparable to these other pipes here, ductile, clay, and concrete. Okay, so it was just highlighting the benefit of the flow for PVC sewer pipe. All right, this was the LCA study done by Sustainable Solutions Corporations. If anyone is wondering, it's very convenient. PVC just happened to win in every category. But it wasn't just, there's other LCA studies done that found similar results. So I just want to show that. This was done by Purdue University. So they looked at environmental impacts. These are different impact categories, different ways a product can impact the environment. And they found PVC has the lowest environmental impact compared to ductile iron, fiberglass, and concrete. So it's not just this one LCA report that shows this. This is one, I think the study references some others that looked at LCA comparisons, and you find that PVC comes out to be the lowest. Basically what that establishes is it's a low energy product and it's a low environmental impact product. Okay, so that was 2015. Now, one of the good things about this ISO standard for EPDs is that they have a time frame. They say it's a 5-year time frame. After 5 years, it's considered expired, and then if you want another EPD, you have to do it again. And that's good because changes can happen in manufacturing of a product, right? It can look good 1 year, and then a decade later, it can be horrible. So that's one of the good things. This is required to renew your EPD or do it again. So we did that one, the first one in 2015. We were supposed to do it in 2020, but I guess COVID, so 2023 is when we redid it. And so that's what you have in front of you. So the one that looks like this is what you have. And so if you wanted to look at the results, let me just skip ahead real quick. Well, I'm too far ahead. Anyways, we'll look at the results in a second. So one of the things that's in this document is a section called any health and safety discussions, or it says disclosure. This just gives general statements about the health and safety of PVC pipe. So again, NSF did this report, all right? So I'm just highlighting some of the things. I'll highlight one in particular. This document states there's no harmful chemicals that come from the pipe to the water, okay? So this, again, was an evaluation done by NSF. And so there's other statements, and I'll talk about it more in detail, the PFAS and microplastics. Those are the hot topics. But anyways, there's a section that talks about that. It's just a way to just verify there is no known harmful chemicals coming from the pipe into your water.
So no known chemicals from this 2023 report. But if a PVC pipe's been in the ground for 40, 50 years, does that same comment apply to something manufactured 40 years ago?
Okay, good question. So generally, yes. So in other words, this statement is on PVC pipe in general. Now, what if there was some odd manufacturer 40 years ago that didn't follow any standards? I mean, you can't do anything about that. And I don't think that's not really, when PVC came out, let's say in the 50s, you probably had some odd manufacturers that were just spitting out pipe. Once the standards that control the quality of the pipe, and that affects water quality, NSF, and there's a few others that came out. That happened in about the 60s and 70s. Once that was established, you didn't see this happening in the PVC industry, right? So this is a general statement about that in general. The PVC industry is got that control.
When the NSF does their NSF 61 testing, Jay, do they do accelerated aging to extrapolate and for like future degradation?
That's a good question. I don't think they do a test like that. But I think the tests that they do, it would account for a long-term. I'll just say is there wouldn't be any difference long-term. So they test for certain chemicals, right, that could potentially come out of PVC. You have to be non-detect to pass. I don't think there would be anything that would cause, after 50 years of use, that stuff could come out. They have that test set up to be a certified safe for water use. So however they do it, it's meant to apply to the whole life of the product. I mean, I don't know if they do anything special, but I think they know that if it doesn't show up here, there's nothing that would cause it to show up.
Same base level of testing we do on any product.
Exactly. They do this for all products that are touching potable water, meet NSF. This is what they do. Yeah. Okay. And again, I'll talk about more of these when I get to the other document. Okay, so in general, this was the EPD. We had to redo the LCA, right? We had to relook at the environmental stuff. Skipping all this, I'm just going to point out one major thing, which is we did find one difference from the 2015 to the 2023, which is an overall reduction of carbon output by 6%. So our carbon footprint decreased, all right? A little bit, but it decreased. And that was because there's a few things that decreased in the less electricity use, and that was a big factor. I'm going to zoom in on those aspects in the next slides, but that's the main difference with PVC pipe, and that's why it's so good to have this ISO EPD. When you do it again, you get to see what changes happen, right? Okay, this is just another statement on the health and safety aspects. In any stage of the pipe, there's nothing that would cause a health concern with PVC. So they just had that discussion in this EPD. And so this graph here just shows how you would read it. So each pipe product, like 8-inch DR18 or 24-inch DR25, it's going to have a table, and it's going to have these different environmental categories. I think the only thing most people care about is the global warming, the CO2, and that's what's this GWP, global warming potential. That's in units of kilograms of CO2. All right, so that's you just look at that, and it has the value for the different stages. I think it has the total, or if it doesn't, you may have to add up the total. But that's just how you read it, okay? If you wanted to assess those values, you just go to the table and add up those global warming values. Okay, so this zooms in at the environmental impacts now. So this graph just shows like comparisons. This is for 8-inch DR18. And so this graph shows the different environmental categories. Here's global warming potential, okay? And here is the total energy usage. I'm not an environmental expert to tell you what any of this means. I mean, smog, acidification, ozone depletion, you may have to look that up, but I think most people care about global warming potential anyway. All right, so the different colors on these bars are the different stages in the life of the pipe, okay? So this light blue is the manufacturing of raw materials. This dark blue is the use stage. That's pumping energy, right? What this shows is that throughout the life of the pipe, the use stage, the pumping energy, that contributes most to global warming, way more than the manufacturing of the pipe. It's almost relatively nothing compared to the use stage. And that's a true statement for pipe materials in general. It's not so much the manufacturing of the pipe, it's pumping water through that pipe. That's where all your carbon footprint's coming from, okay? But just to show that, I mean, if this was done for other pipe materials, the manufacturing would probably be a little bit bigger. But for PVC pipe, the manufacturing is almost nothing compared to the pumping energy. That's all this is showing. Same thing for the energy usage. There's very little energy usage in the beginning stage of the pipe. Okay, so this is for sewer pipe. Same thing, except for sewer pipe, we don't have any use energy. When that pipe, it's a gravity pipe, right? So there's no energy being used. So now here for global warming, it is all in the beginning. This is raw material, the manufacturing of the raw material. So that's all this is showing. So if you basically remove that the pumping energy, then it becomes the raw material. More so than the manufacturing of the pipe. The gray is manufacturing the pipe, or transportation. It's actually so that's PVC resin takes up most of that carbon output. So this is just going into more zooming in of the stages. Which stage in particular is causing most of the carbon output? Okay, so this just compares 2015 and 2023. Again, it's because of the electricity decrease in these manufacturing plants. That's why the overall impacts decreased. That's all this one here is saying. Okay, so another comparison. So this is the comparison of the two studies side by side. So this is, 2015 is the blue, and 2023 is the orange. So here you can just see for each category what decreased. They all decreased by a little bit, okay? So something good that's going on in the PVC industry. We're being more sustainable, more and more, I guess, each decade. Okay, now how does PVC and PVCO pipe compare? I'm going to talk about what PVCO is, but just for right now, think of those as two different pipe materials. What we find is that PVCO is just slightly, it's almost equivalent, but for the most part, it's just slightly less impactful to the environment, okay? They're very close, but there's a small difference. So this is throughout the entire life. And then if you look at cradle to gate, that's where the difference really comes in. So that's the manufacturing. Manufacturing PVCO is just slightly less impactful than PVC. Okay, so PVC itself is already very sustainable. PVCO is slightly more sustainable. Okay, so that's the LCA. Now I'm going to get into a little different topic, but I just want to recap this LCA thing. Again, the main takeaways is the PVC industry is the only industry that's done this third-party certified study of the environmental impacts, okay? And what does that mean? Well, it means we're the only ones that give you the results of that study. I'm gonna compare this to, not to pick on other pipe materials, but ductile iron. What you'll see them do is they'll say, we are certified by this green organization. They're called SMART certification. So this organization, what they do is they give like ratings, gold rating, silver, bronze, and they say, oh, ductile iron pipe is our gold rating. And they say, we've done the LCA, we've done all this assessment, we give ductile iron gold, and so they tout that. That's good, I don't want to harp on them, but the problem is, the results of that LCA, you're never going to find it, okay? You will not, even if you ask them, I don't think they'll give it to you. Because they didn't do it by ISO. They didn't do it by a standard that requires transparency. And there was no third-party review. It was just that SMART certification. They just did it. There was no third party that looked at it. Okay, so that's why I'm emphasizing this. It's important to keep in mind, we did this for a reason so that we can be above and beyond. And we're open. If you guys want to look at how we're impacting the environment, it's right there. All right, so that's, I think, the main thing to keep in mind with the LCA of PVC pipe. Okay. All right, now on to environmental, health and safety. I should have retitled that. This is a document that we came out with earlier this year. This is to address a lot of claims about PVC pipe, how it's dangerous. Have you guys been hearing that a lot? The PVC is potentially dangerous. Our competitors, I won't mention them, Dipper, but they've been bringing this up a lot. So this document, the goal of this is to address all of the claims and to set the record straight, okay? So I'm gonna go through that. Okay, if you look through the document, there's a paragraph for each topic. Just to run through this, first things first, we said this already, we are NSF certified. NSF is the organization that certifies every product in contact with potable water, even ductile iron, okay, copper pipe, HDPE pipe, steel pipe, all that has to go through NSF. We go through NSF. So it's a very rigorous standard. If you can actually compare NSF to other standards around the world, NSF is one of the most strictest standards, okay? If anyone has any concerns about wildfires, this is a big concern in the west coast of the US. I don't know how big of a concern here it is, but if you may have heard some things, PVC pipe, when it's buried, has no issues with wildfire, okay? There's been a lot of conflations. Some guy in Purdue did a conflating study. What he was showing was if the pipe is above ground and there's a fire, then there could be problems with the pipe. Of course, and then he claims that PVC is a problem. The problem is PVC is below ground. And we have a document on this. So no chemicals leach through the pipe, no chemicals come from the pipe when it's below ground and there's a wildfire. And we've spoken with the utilities in California that have had those wildfire issues. They were using PVC pipe for the fire flow, and the pipe is still in use today. All right, so there was no issues with PVC. Okay, microplastics. This question comes up often. In general, microplastics, the way it can come out of any plastic product, there has to be a mechanism for that to be released, okay? A mechanism could be extreme high temperatures can release microplastics, or any mechanical means of scratching or damaging that plastic product can release microplastics. The closest thing you have to that, you don't have that in a PVC pipe in a service. There's nothing that would cause that kind of degradation. PVC pipe simply does not degrade, and you saw a presentation earlier on that. Now, even if you're cutting pipe or tapping pipe, when you flush the line or that gets removed, but while it's in service, there is no propensity for microplastics to come out into the water. Now, there's some studies that have looked at this in more detail. One study is in Europe that looked at a water system, and they took water samples from the treatment plant, in the distribution system, and at a tap, I guess someone's home's tap water. And they analyzed the plastics that they found. The PVC was, it was a fraction of a thousandth of a percent. It was so tiny, especially compared to the other types of plastics, that you would not expect that PVC to come from the pipe. If PVC pipe was leaching microplastics, that value would be a higher number. I mean, it was like 0.0000 something percent was a PVC. The microplastics were coming from something that was polyethylene or polypropylene or some other type of plastics. The owners of the utility had no concerns with their PVC pipe from the result of that study. There was some other source, and they couldn't find out what, but something was bringing in plastics, but it wasn't PVC, okay? On top of that, we actually know, I don't know if you can Google this right now, we know what the sources of microplastics are in our everyday life. Does anyone know what they are? Top here, what are the sources of microplastics? Polyester? Yes, from your clothes. Yep. So clothes is one? Food? No. I don't know about food. So yeah, it's not even that. That could be a source. That's not the top source though. I think that's actually smaller than, there's other ones that are more major. Go ahead. You're driving down the road, your tires. Tires, clothing, and there's one other that everyone uses every day, hopefully. It's personal care products like soap, toothpaste, things like that. So we know those are the sources of microplastics in our everyday life and in the water systems. If PVC was a problem, we would have identified that because we've already identified other these sources, right? So we have the data to know by the mechanisms of how PVC pipe behaves and the data that's out there, PVC pipe is not a source of microplastics. But one thing we know, it will go into water sources by like tires or whatever. I think that's how it gets into the water system. Through tires, and it'll get to a water source, and then it goes through the whole distribution system. And now there are probably some other potential areas that we don't know. Because there are other types of plastics that one study found, and I don't think they were able to conclude. But all to say is, we would know if it is PVC. Yeah. You had a question? Or I thought you had. Okay. All right. And then what else did I have here? Okay, PFAS. That's another big one. There is no PFAS used in any of the manufacturing of PVC pipe, nor any of the ingredients that's used in PVC pipe. All right, so the ingredients are used to help aid in the manufacturing of the pipe, help some of the properties, mechanical properties of the pipe. None of that has PFAS. Another question that comes up is, can PFAS that's in the ground permeate through PVC pipe? There was a study done on both HDPE and PVC. PFAS cannot go through either material, HDPE or PVC pipe. Okay, so PFAS is not a concern. Okay, all right, so I just wanted to, I don't know if you guys have heard of these claims, but hopefully this addresses it. If one of your clients brings this up, you can point this document or come to us or come to Westlake, and we can provide you that data. Okay. Okay, yeah, and these are other things that have been charged against PVC pipe. No vinyl chloride released. That's actually something that's been Dipper's been harping on this. Vinyl chloride, when it becomes polyvinyl chloride, it's not vinyl chloride anymore. Those are two completely different things. So no phthalates, organotins, nothing like that. So all to say is this is all talked about in the document. I'm not going to harp on it anymore. We have the data and knowledge to know that this is not an issue. Okay. A lot of this is, some of this is kind of repeat. Oh yeah, this kind of repeats the LCA stuff, so I won't go into that. All right, I think this is my last slide here. In case you're wondering, how do we know or how do we control or certify PVC pipe? This is a list of all the organizations that either have a certification, a standard, a test, or some sort of water quality control test on PVC pipe. Basically, PVC pipe has to go through all this before it goes in the ground. Okay, I don't believe there's any other product, any other pipe material that has to go through all this. It's just PVC, basically. Factory mutual, kind of like a insurance company for industrial. They insure plants, products, things like that. That's my presentation. Thank you for your time today.